Okay, here's the notes for Chapter 8, Section 5 on trapezoids. Go ahead and put in the date up here that you're filling these out today. Let's start with a definition. Definition of a trapezoid is a quadrilateral with exactly one pair of parallel sides. All right, and usually those sides that are parallel are your bases. It's the top and the bottom of your trapezoid. The other two sides are called the legs of a trapezoid. All right, so trapezoid is a quadrilateral, two parallel sides. All right, down here. The next definition is a median of a trapezoid. The median of the trapezoid connects the midpoints, I guess, of the sides or of the legs of a trapezoid. So looking over here at your picture, P is the midpoint of this side. We can see that with our tick marks here. Q is the median of the right hand side, that leg right there. Again, those tick marks mark that it's the median, showing us that it's equal. Just to point out something else here, notice our markings for our two parallel sides indicating that we have a trapezoid. All right, moving down here, there's some properties of the median of the trapezoid. The median is going to be parallel to the bases, and the length of the median, so we're talking the distance, or the length of the median is half the sum of the bases. So I would add base 1 plus base 2, so that's maybe the top base and the bottom base, and then we're going to divide that by 2. A median of a trapezoid is also called the midpoint. Not midpoint. Let me fix that. It's the mid-segment. Of your trapezoid. So that median, which is right here, I'll take that off. I'll draw an arrow in there for you. That right there is your mid segment or your median. Can't write there. I-A-N. There we go. All right, so now we're going to use what we know about our trapezoids here and do some examples. Make this a little bigger for us. So example number 1 right here, we're going to find the length of MN, and MN is our mid-segment. Okay, and if we know that AB, so the top base, is 12, and DC, that bottom base, is 18. So we are going to add up our bases, so base 1 plus base, not another 1, base 2, and divide that by 2. So base 1 is 12, plus our base 2, which is 18, divide that by 2. Have to do what's on top first. 12 plus 18 is 30. 30 divided by 2 is 15. So our mid-segment is 15. Okay. Moving on to the next example, we're trying to find the length of AB, which is one of our bases now, given that MN, which is our mid-segment or our median, is 22, and our bottom base is 30. So again, we're going to use our formula that's right there. We're going to say base 1, which we don't know, so we're going to call it x, plus base 2 divided by 2 is equal to 22. All right, now in order to solve for x, the first thing I'm going to do is multiply both sides by 2 to get rid of that 2 in the denominator. So I've got x plus 30 is equal to 44. Now I'm going to subtract my 30 here. I've got x is equal to 14. So I know that that top base, AB, is 14. All right, and then the last example down here, finding the value of x. Again, we've got one more example with that same formula. So we're going to say our base 1, which is 10, plus our base 2, which is 2x. That divided by 2 is going to be equal to 7. Okay. Again, we're going to get rid of that 2 in the denominator first. So my first step is going to be to multiply both sides by 2. Gets rid of that here. So I've got 10 plus 2x is equal to 14. Now solving for x, I'm going to subtract 10 first. So I know 2 times x is equal to 4. Divide both sides by 2 here. And I've got x is equal to 2. All right, let's circle that answer and just double check. We were just trying to find that value of x, so we are good. X is equal to 2. All right, we're going to go talk about an isosceles trapezoid. Just like an isosceles triangle, I have 2 legs that are congruent. Trapezoid with 2 legs. The legs are the non-parallel bases. They're congruent. And the base angle theorem for a trapezoid says that each pair of base angles in an isosceles trapezoid, so our base angles, oops, let me get that highlighter here. Base angles of the trapezoid are congruent. Okay, so just like in an isosceles trapezoid, we have congruent sides and congruent base angles. Same thing is true for your isosceles trapezoid. Notice the markings for my congruent angles, and my other base angles here are also congruent for my isosceles trapezoid. All right, and looking at the last example, we are going to determine the 3 missing angle measures in the sides of the triangle. We're going to use what we know here about parallel line. Oops, not the highlighter. Use what we know here about the parallel lines. Notice my markings here. And we have this angle right here, angle R and angle A would be same side interior angles. So I know that those two added up equal to 180, so I'm going to set that up. So angle R plus 60 equals 180. Solving for angle R, I know that angle R is equal to 120 degrees. All right, and because we have an isosceles trapezoid here, I also know that this other base angle is 60 degrees, and I also know that this other base angle up here, since we found that angle R was 120, we know that it is also 120 degrees, because again, on the left-hand side of that parallelogram, we also have same side interior angles, and when we're working with parallel lines, same side interior angles add up to 180 degrees. So I've got 2 60-degree angles here and then 2 120-degree angles at the top. Homework is listed right here. We're doing assignment 5 first, and then assignment 6, which practices 8.4 and 8.5. So this is your last video. The one you should be doing right now after this video is assignment number 5. And then when you complete that one, you can move on to assignment number 6, which just gives you more practice on 8.4 and 8.5.